Okay, so in this video, we're going to look at simplifying expressions using exponent rules. Now, in the example one here, I have 2 times d to the third power all raised to the negative second power. Now, remember from our rules, anytime you raise something inside the parentheses to an outside power, what we're really doing is multiplying the exponents together. Notice I have two bases in here. 2's a base and d's a base. I know the exponent on the d, it's a 3. I need to know the exponent on the 2. Anytime you have a base that's alone, it's really got an exponent of 1 on it. So when I raise a power to a power, I'm multiplying the exponents together. So I'm taking 1 times negative 2, which is negative 2, so I get 2 to the negative second power. And then I'm taking 3 times negative 2, which is negative 6, so I get d to the negative sixth power. Now, when you simplify an expression, it's important to remember you can never leave negative exponents in your answer. So we need to simplify negative exponents. Recall that negative exponents always switch to the opposite side, the reciprocals, and then the negative exponent becomes positive. So, for example, if I have 2 to the negative second times d to the negative sixth power, right now all of that is over 1. What's going to happen is these two expressions will move down. So I'll get 2 to the second, d to the sixth. Now I cover this in another video of why they move to the bottom and become positive. But after you know why, you just need to remember that negative exponents will drop to the bottom and will become positive exponents. Okay, and then we have a 1 on top. So it's going to be 1 over 2 squared d to the sixth. Then we just need to simplify what is 2 squared. Well, 2 squared is really the same thing as saying 2 times 2, and 2 times 2 is 4, so I would get 1 over 4 d to the sixth power. This would be my answer. Now, normally it's also important to note that anytime you're simplifying an expression, you know when you're done because there's no other exponent rules that you can do to simplify it any further. All right, let's look at number 2. In number 2, I have 3x to the second y to the negative third power all over 2x to the negative third power times y squared. And all of that is being raised to the third power on the outside. Now, just like in example 1, I'm going to take this power and I'm going to distribute it to every single exponent inside of the parentheses. Okay, it's going to every single base. Now, it's important to remember because the number one mistake that people make is they take this number and they multiply it by this base, but we never multiply exponents to bases. It's only exponents to exponents. So I have to remember the exponent on the 3 is really a 1. So when I distribute this in, I'm now going to have 3 to the third because 3 is getting taken to the third power. Then when I take 2 times 3, I get 6, so this becomes x to the sixth. When I take negative 3 times 3, that's negative 9, so I get y to the negative ninth over, and then similarly, I'm distributing it to the bottom, so it's 2 to the third power, which is 2 to the third power. Negative 3 times 3 is negative 9, so I get x to the negative ninth. And then y to the second power, if I distributed that to the 3, 3 times 2 is 6, so I get y to the sixth power. Now, likewise, like we saw in number 1, negative exponents switch sides. Okay, so notice I have two bases that have negative exponents. I have a y that has a negative 9 as an exponent, and I have an x that has a negative 9 as an exponent. The negative exponents switch sides. So this is on the top of the fraction. It's now going to move to the bottom of the fraction. And when it moves down, the negative exponent now becomes a positive 9. Similarly, the x that's on the bottom is going to move up. And when it moves up to the top part of the fraction, its exponent will switch to be a positive as well. Okay, so both of those are going to move. So our new expression is going to be 3 to the third x to the sixth times x to the ninth when that moves up. And then on the bottom, we are going to have 2 to the third y to the sixth, and then we're going to get y to the ninth when this one moves down. Now, we still have more to simplify here. 3 to the third, Well, that is 3 times 3 times 3. 3 times 3 is 9. If I multiply by another 3, I get 27. So 27 is on top. If I take x to the 6th times x to the ninth, remember anytime you multiply like bases, we add the exponents. So we get x to the 15th. And then this is going to be over 2 to the third, which is 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, so we get 8. And when I take y to the 6th times y to the ninth, I add the exponents because they're like bases, and I get y to the 15th. Once again, there's nothing else I can simplify, so I know this is my final answer. Now, it's also important to note that you could solve this another way. As long as you follow your exponent rules, the order in which you apply the rules doesn't matter. What matters is that you do one rule and then another rule and another rule, and then you know when you've arrived at your answer, when there's no other exponent rules that you can apply to simplifying it any further. All right, let's look at one last example. Here I have 3x to the fourth, y to the 0, all over 9y to the third, x to the negative fifth. So one thing that I see right off the bat is I'm taking 3 divided by 9. Now notice these are both bases. So I can simplify this like I reduce a fraction. I know 3 goes into the top number, and I know 3 goes into the bottom number. So I can divide a 3 out of both the top and bottom, and 3/9 is equal to 1/3. Then x to the fourth, that's positive, so I'm going to leave it on top. Y to the 0, anything to the 0 power, I know is equal to 1. So I can get rid of that and make it a 1. Y to the third's positive, so it's going to stay on the bottom. And then x to the negative fifth, negative exponents move to the other side of the fraction are the same thing as the positive exponent. So this x to the fifth is going to swing up. Now I want to combine my x's. So if I take 1 times 1, well, that's just 1. If I take x to the fourth times x to the fifth, well, it gives me x to the ninth when I add the exponents. And then that's over 3y to the third. Now it's important to note you don't need to write this one, it's assumed in math, so really a lot of times we write our answer as this: x to the ninth divided by 3y to the third.